In this video, we're going to look at PARMS planning scenarios, which are the simulation tool within PARMS that allows renewal planning to be projected over the strategic planning horizon to try and determine how much money should be spent. The scenarios are accessed via the modeling paneling. We switch to the planning scenarios and we see that we are building up an exploratory of scenarios with their associated saved snapshots. Start a new scenario by clicking in the panel or by clicking on the icon here. As usual, we can rename as we wish, and then we can set up the scenario for our use. In this area of the scenario, we set up the convergence criteria. So as set at the moment, when I run the simulation, it will do at least 40 iterations and it will try and get to a convergence criteria of 98%. If it hits 1,000 iterations before it reaches this criteria, it will stop. The higher this number, the smoother the results. Rough results will be obtained with a criterion of around 95% or less. Smoother results will be obtained with a criterion of 99%. In this area, we set our triggers for renewal. We have various options. We can define triggers for various materials, various area classifications, and we can specify whether it's a failure or an interruption, and how many have to occur in a 12-month period, and also a failure rate limit. At the moment, I am essentially modeling a strategy where all pipes are replaced if they fail 3 times in 12 months. If I wish to put a failure rate constraint on it, I can do that. If I wish to add another more detailed trigger, I can also do that. So at the moment, I've now added another trigger. So all AC pipes in any area classification will now be replaced if they're predicted to fail at least twice in a 12-month period. The other option I have is to specify, instead of failures at the asset level, I will replace due to service issues in the shutoff block. I can do that by changing the trigger to interruptions. So this trigger here is now focusing on all materials, all area classifications. If there are 3 interruptions in a shutoff block, it will trigger renewal. So in the simulation, for each pipe in each year, the software generates random numbers and determines whether, according to the models, the pipe or pipes are predicted to fail. If the pipes are predicted to fail by one of these triggers, the software then looks to see if the benefit cost calculation is enabled. If it is, it will make an assessment of the benefit cost calculation based on the settings. If we open the settings and jump down to our prioritization, you can see here we have this box ticked, which means that we are using social costs in the benefit cost calculation. In effect, if I then enable this box here, the simulation has to pass through these triggers and then we'll check to see if the benefit cost calculation, taking into account OPEX, CAPEX, and risk cost, is above the threshold that I've specified. A BC threshold of 1 means that for every dollar I spend to renew an asset, I remove $1 of risk and OPEX. To repeat, there is a gateway, so these are checked first. It will then check the benefit cost calculation. If it passes that, it will then check to see if there is sufficient budget to do the renewal that's being modeled at the time in the simulation. At the moment, you can see that we have $0 available, so the software will not make any renewals irrespective of what's set up here or what's set up here. To be more realistic, I can set it to the current year and I can specify either an unlimited budget, which simply means that however many pipes need to be replaced to meet these triggers and this benefit cost calculation will be replaced. I can, however, specify that I have only got a budget of a certain limit, and then any pipes that fail and pass through this gateway, they will only be replaced if I haven't, in that year of the simulation, spent $4 million. As here, where I can add a row, I can also add a row here and specify budgets changing into the future. So with this setup, in the simulation in the first year, this software will allow $4 million worth of renewal to be made. In 2030 of the simulation, it will drop the budget available down to 1 million. So for the purposes of this demonstration, I'm going to set the convergence criteria relatively low, and then I'm going to run on the whole of the network. So when I press run on the network, the simulation tool tells me that I'm running on the master costs and the master settings and asks me if I want to run the simulation. I know which costs and settings I'm running on because they're also down here in the status bar. If I'm not satisfied, I can click no and select the settings that I want to use, which are selected in the tree. And now in the status bar, you can see I have changed the cost and the settings that I'm using. Again, if I run the network, the software will tell me that I'm now running on the whole network with the costs and settings I have just selected. If I run the simulation, the software will go away, and for each pipe in the network in each year of the simulation, it will essentially model whether the pipe fails, whether there are failures in the shutoff block, and application of the algorithms and the rules dictate how much repairs, renewals, and interruptions occur across the network. As before, I get quite rough results if I set my convergence criteria quite low. So I'll set it a little higher and I'll run the network again. This time you can see that the results are a little smoother, and similarly I can make them even more smoother by increasing this convergence criteria or defining more minimum iterations. So now I have my results. I can see what the total cost of the strategy I'm running, how much repair OPEX will be spent, how much renewal I will do in each year, and also how much risk I will generate. So this is a measure of how much risk is realized across the network. This is the total cost, which is the sum of these values. I can look at these in the data view, and as usual, copy that table and use it in Excel for my own purposes. Going back to the results and the graphical view, if we go across each of the tabs, you get the cost by category, so OPEX, risk cost, CAPEX, and total cost, how much each material is costing, the failure rates predicted in the network. I'll have the failures numbers, which I can look at the total failure, and according to my strategy, I'm actually managing to drive the failures down overall, and I'm achieving that by spending this amount of money each year. Again, I have tabulated data as well as graphic views. If I'm interested in saving that result as a snapshot, I go back to my setup page and press the Save Results button, and then it will save a snapshot of the results underneath the scenario which generated them. In general, it's a good practice to build up our scenarios in terms of folders and name the scenario for something that's meaningful in terms of the target materials, the failure rates, etc., and also name the snapshots. So again, we can refer to them in the future. So if I close down my scenario, I can open my scenario again and it will be saved to the settings that I saved it to. But I can also open up the results without running the simulation. Therefore, I have a record of the results for use in my analysis. PARMS can also be used to run on the selection. The run selection runs whatever is selected via the Network Explorer. So let us imagine I want to run on a subset of the network defined in terms of suburbs. So I would start a new query and I renamed it suburbs. I'll then go into the suburb part of the query controller and I will select the top 3 suburbs. If I go over into the GIS display, you can see I've selected 3 suburbs here. It makes sense to add in Ravensgate. So let us add in Ravensgate, rerun the network. We have selected this part of the network and we're ignoring this part. If I return to my planning scenario and look at my status bar, it now tells me that I'm running on the Open Query suburbs. Let us revert to using the master costs and the master settings and then run this. I simply press this button and it will show me the same information. If I'm satisfied, I can run the simulation. And again, the software will generate failures and management responses across the network, but only for the selection that we have made in Network Explorer. So this is now the results for applying this strategy with these budget limits on this area of the network.